let's say we're given the fraction 5.5. Right, so I'm writing this here so you can see what I am trying to express. Okay, the way you convert from a mixed fraction to an improper fraction is you multiply the denominator by the whole number in the front. Right, so you multiply the denominator by the whole number in the front, and whatever you get, you add it to the numerator. So if I have to do that steps here, it'll be 2 times 5, which is 10. 10 plus 1 is 11. And 11 over 2 is 5.5. If I was given 7 and 1/3, it will be 7 times 3 is 21. 21 plus 1 is 22 over 3. That's how you can convert from a mixed to an improper fraction. Okay? Okay, just something that I need to bring to your attention. You see, the way we write maths is very important as well. Because if I had 7 and 1 over 3, this is saying 7 times 1 over 3. However, this is the reason why I wrote this whole number over 2 lines. 7 and 1 over 3. Because this 7 is the whole number in front of the fraction part. Understood? So that's the reason why you need to know. Because if it's 7 and 1 over 3, this is 7 times 1 over 3. Right? It's like similar to saying x and 1 over 3 is actually x over 3. You're multiplying. But however, if you had it over 2 lines, then this is a whole number in front of the fraction. I'd be very, very careful with how you write maths. That's the reason why I wrote it here big, so that you could see the difference. Okay? So notation is very important. Let's look at the converting from improper to mixed. So let's say you was given 11 over 2 and you need to write it in this form here. This is what you do, right? Very simple. Your first step is to take, listen to me, is to take the number and put it into your calculator. So say 11 divided by 2 is what? 5.5. 5.5. And this is where we learn something very important here. You see the 5 to the left of the comma. This is what we call the whole number part. In decimals, this is what we call the whole number part. And the 5 to the right, or any number to the right of the comma, is what we call the fractional part. It's called the fractional part. Right? Very important. So now this is what we're saying. This 5 here is actually the big 5 in front here. In front of the fraction. And you can see that's how we get that there. However, this is what we are going to do. Then here, that's step 1, right? Put it into your calculator. Step 2 is to multiply the whole number part, which is 5. Right, so remember, this here represents the whole number part, by the denominator, which is 2. So this represents the denominator, which is equal to 10. So now what we can do with this 10, what do we do with this 10? This is what we do. We will write this here, 10 over this 2, but there's something wrong with this question because I have an equal to sign here. So how can the left hand side be equal to the right hand side? By adding 1. So now can you see that this 11 over 2 is actually the same as 10 plus 1 over 2. But what does this enable me to do? Now it enables me to split the fractions into 10 over 2 plus 1 over 2. And now I can further simplify this as 5.5. Can you see that? Can you see that? Remember, yeah, this 5 is written across 2 lines, right? But because I'm running out of space, I can't do that, right? And if you look at this, this is the interesting part. This is the interesting part. If you look here, this 5 here comes from the whole number part here. This half here comes from this fractional part. If I have to write this as 2 parts, the whole number part plus the fractional part, it will be 5 plus 0.5, which will be 5.5, right? So that's why we're saying that this whole number part here, we multiplied by the denominator so that we can get the 10 there. And we have to obviously retain the equality. So what number is missing? Right, so let's do another more complicated example so you'll understand the idea more clearly, right? So let's do something like, let's say I gave you 788 over 210. Let's say we were given that. How would we do this? First thing is to put this into the calculator and get the decimals. So basically with the whole number part, we're basically asking how many times can 210 go into 788 without a remainder. Here we're asking how many times can 2 go into 11 without a remainder. So if I think about it, right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, we did this in primary school. How many groups of 2s can I get? I can get 1, 2, 3, 4, 5 groups of 2. So this is how many times 2 can go into 11. That's the exact same idea here, right? So now we have something like 3,75230 or 80. Right? So that's like some fractional part. So this is the whole number part, but we're only concerned about the whole number part. Now that we have 3, so we'll say 3 times 210 is 630. So 630 over 210. But we cannot just write 630 here because we have to retain the equality. We cannot change the question. Right, so whatever's in the numerator here has to be the same in this numerator. So we're saying that 630 plus some number must give you 788. What is that number? So it'll be 788 minus 630. It'll be 158. 158. So 630 plus 158 will give you 788, and 210 and 210 are the same. But now we can separate this fraction into two parts. This is the whole number part, and this is the fractional part. So 630 over 210 is 3, and it'll be 158 over 210. Now watch here. If you put 158 over 210 into your calculator, watch what you get. Watch what you get. You get 0.752380 ... which is the same as the fractional part. So this is why I said that this is what we call the whole number part, and this is what we call the fractional part, and it coincides precisely with the decimal representation. Because of the decimal representation, that's the whole number part, and this is the fractional part. It has to be the same. Remember I said that these representations may look different, but it has to give you the same information. And the reason why they look different is because they maybe can serve different functions in different applications, but they give you the same thing, right? They give you the same thing. Okay, so that's what we need to remember here, and it's very straightforward. So now we understand how to convert from mixed fractions to improper, and how to convert from improper to mixed. We understand how we can correlate with this decimals and fractions, right, and the two parts of the decimals. I think in the next video we will discuss multiplication and division of fractions, and then lastly I will discuss the 6 properties pertaining to fractions that we will, or 6 or 7 properties pertaining to fractions that we will use so that we can simplify our process and speed up our process when dealing with fractions.